If you work in finance, Excel is almost certainly your go-to tool for model building. Whether you're building a cash flow forecast, valuing a company, or performing sensitivity analysis on planning scenarios, choosing the right functions as you build can save you time and help you produce high-quality, robust models. Let's dive in and look at some of them. Let's first look at the XLOOKUP function, which is great for scenario modeling or sensitivity analysis on your workbooks. Here we have a very simple model where 3 divisions of a company have been asked to provide their growth expectations for the next financial year based on 3 cases. We'd only want to see one of these scenarios at any time in the budget, but we want the option to be able to come to this sheet and change the scenario and see what the effect on the budget is. So we want to fill in these cells here the growth percentages for the current scenario. So in cell D14 we'll build an XLOOKUP formula to pull through the base case growth for division A. The value we want to look up is the chosen scenario, which is in cell C11. We'll fix the reference to that so we can pull the formula down afterwards. Our lookup array is the base case to scale back column titles, so D5 to F5. And again, we want to hard code those because they will be the same for each of the divisional formulas. And then for division A, we want to pull in row 6. So we pull in D6 to F6. The next criteria is if not found. We'll leave that blank, so it will just return an error if it couldn't find anything. In this instance, we want to find an exact match. So we use 0. In search mode, we want to use first to last. So that returns for division A the base case growth of 10%. And if we drag this down, because we've fixed the formula references, we get division B 12% and division C 15%. And now if we change the base case to additional investment, we get the percentages in that column and the same to scale back. Why this is so useful for scenario modeling and sensitivity analysis is that now all you have to do throughout your model is refer to these 3 cells here for the growth percentages. I focused on XLOOKUP here because it replaces the old HLOOKUP and VLOOKUP formulas, which are both prone to introducing errors into workbooks if you end up inserting additional rows or columns into your scenario tables. If you're using a version of Excel that doesn't have XLOOKUP, I'd suggest you use our next formula or combination of formulas, INDEX and MATCH. Here we have the same scenario worksheet as before, and this time I'm going to build up the criteria for the chosen scenario using the INDEX and MATCH formula, which is a combination that will work in older versions of Excel. And then I'll show the same formula using the new XMATCH function. The combination of INDEX and MATCH gets around the problems of HLOOKUP and VLOOKUP because it can refer to the row or column that it wants to return data from directly as a range rather than using an absolute position. Let's first do the match part of the formula by finding out where the chosen scenario fits within the titles of the growth scenario table. So we're looking for our chosen scenario, which we'll fix within the titles. Again, we'll fix, and we're looking for an exact match, so we'll use 0. So it knows that the base case is the first value that it's found within that range. If we change it to additional investment, that becomes 2. So it's the second out of 3. Then what we need to do is wrap that in an index function. So for division A, we want to return a cell from the range of cases here. And for the additional investment, we want to return the second cell in that range, which is what our match function has returned. So 0.15 is the 15%. Let's just copy that into the table here where it's formatted as a percentage. Now let's try the same formula using XMATCH. So this time we're asked for our lookup value within our lookup array. So it's very similar so far to the match. Now we have a greater range of match modes. So you have the option for wildcard or regex matches. But for now, we're just looking again for an exact match. We have an additional criteria for the search mode. So you can search first to last, last to first, or binary searches. But again, let's, for simplicity, choose first to last. So for scale back, we get the match value of 3. We'll copy that and put it into this formula replacing the match. And we get exactly the same result, but it's just a newer formula that has certain additional features that you may find useful. Most financial modelling involves analysing data into discrete time periods, usually months, and this is where the EOMONTH or end of month formula can be useful. Here I've got a simple table where I want to pull out 12-month periods for the year based on the starting date in cell C3. Now EOMONTH works on month 0 being the current month, and we want this date here to be the first month of the year. So we use EOMONTH that date, and we'll fix that so we can pull it down. And then we want the value in C8, which is 0, which gives us the end of January. We pull all that down, and we get everything up to the end of December. That will shift based on the date we have here. So if our financial year started on the 1st of April, those dates will shift accordingly. Let's try and build this with a dynamic array instead of referencing a single value. So we'll replace C8 with range. Don't need those. But actually it returns an error because it's an old formula that doesn't actually recognize the array, so it's not converting and spilling that formula. You can get around this with what's called scalar lifting by turning this range into an array automatically for the cell. So there's a few ways of doing that. You can either add 0 to that formula. Performing these calculations turns it from a range into an array. So that will work. You can multiply it by 1. Just the same. You can perform a negative function on it, turns it to a negative and back again, or you can actually just put a plus in front of that formula. So you can make the EOMONTH formula work with a dynamic range, which is incredibly useful with modern financial modelling. What we can also do, instead of having to have this month helper column, we can use our next function, which is sequence. The sequence function allows us to build an array of values. So in this instance, we want an array which is 12 rows, 1 column, the starting value of 0, and then step increment value of 1. And it gives us an array which is exactly the same as the values we've got in our helper column here. So if we copy this sequence formula and replace the scalar lifting that we put into the EOMONTH formula, you can see we get our dates there as well, but we then have no need for the helper column. Not needed at all. We've incorporated everything into one formula that's working just from this start date here. And of course, if you wanted to have a dynamic number of months, you would just replace the 12 rows with however many months you want. And again, you could incorporate that into your scenario planning sheet. When you're breaking data down into time periods, you might want to show the week number that data relates to. So in our example table here, I want to show what week number the month end dates fall into. So I'll start with the WEEKNUM function. We put our date in, and our return types, there's quite a list here. So 1 and 2 are your standard ones. So the week starts on a Sunday or a Monday. And then there is another range for different days of the month. So again, you've got Monday and Sunday as 11 and 17, which return the same values as 1 and 2. And then you have another one, which is type 21, which is the same as another function, which we'll look at in a second, which returns the ISO 8601 date. Well, let's assume the week starts on a Monday. So the 30th of April 26 falls into week 18. Then we have our week numbers as we roll over into 2027 in our 12-month period. You can see it starts again. And if we try and make that a dynamic array of dates, we can see it recognizes that the month ending column is already a dynamic array, so it puts D8 and the hash symbol. And that doesn't work for the same reason that EOMONTH didn't work. So if we put the plus in front and do the scalar lifting, we'll get the dates. Let's try this with the ISOWEEKNUM formula. This only requires one argument, which is a date, because the ISO 8601 standard says that week 1 of a year starts on the first Thursday of that year. Let's copy these down. And you can see that most of them are the same, but where we get into the early months of a new year, you can see there's a slight difference there because of the way that the two formula are working on different start dates for the year. My personal preference would be to use the ISOWEEKNUM formula because it is a standard, but your modeling may require you to use something with a different start date, and that's where the WEEKNUM formula can be useful. Thanks so much for watching this far. If you're finding this useful, it would really help the channel if you could click that like button and consider subscribing to get notified of new videos. Now, let's move on to the next function. Your analysis may require you to calculate the number of working days between two given dates, and we have a couple of options here. We'll start with network days, and you have to give it a start date, which we'll fix as the year start date, the end date, which we'll take from column D for the month end date, and it asks for a list of holidays, which are dates that it won't include as working days. So we have here a list of the UK national holidays. So I've highlighted those and I'll fix those dates. And network days is calculated 21 working days from the 1st of Jan to the 31st of Jan inclusive. Now that's based on a weekend of Saturday and Sunday, which are not counted as working days, and that's inherent in the network days formula. You can't change that. And it's also excluded the 1st of Jan being New Year's Day. You can see there, if I drag the formula down, it's adding up the cumulative working days. Now, if I go back and try and turn that into a dynamic formula by changing that to the range, you can see that you get a value error for the same reason that we had with end of month and the WEEKNUM formula. Again, we just need to turn that into an array using scalar lifting, and you can see that that then spills. The other option we have is NETWORKDAYS.INTL. So we'll give that the same start date, the end date from column D. Now here we have the options to choose what days actually make up a weekend, and this could be useful if you have varying shift patterns, for example, that you have to factor in, or you're dealing with figures for a country that has a different weekend. I'll stick with option 1, which is the standard UK and US weekend of Saturday and Sunday, and then it's asking for the range of holidays again. So I'll highlight those, copy that down. It gives us the same date. We've effectively given it the same criteria for both formula. We try and spill. Again, we have the same value error. If we apply the scalar lifting, you can see that that formula will spill. The text function allows you to turn values into text in a format of your choosing. And this is useful in financial modelling as you can pull the names of days and months out of a numerical date. So we'll use the text function to turn this date into the name of the day. And if I want the short name, I use 3 Ds. And this is the same formatting that you would use if you were setting up a custom date format. So there we have Sat for Saturday. Spill that down. And this does work without having to do the scalar lifting. So the text function is one that does recognize arrays. If you wanted to turn that into the full name of the day, then use 4 Ds and you'll get the full name. And similarly with the month, we'll take the whole range and we'll format that as a short month, or use the 4Ms, turn it into the long month. And if you had a situation where, for example, you just wanted to pull the first letter of a day, if for formatting reasons you needed to keep that very short, then you could wrap that in the left function and just return the first character. The TEXTJOIN function allows us to create dynamic titles for reports and charts. So here we have some data that we just want to bring together into a title. So we'll use TEXTJOIN. Now as a delimiter, for now we're just going to use space within double quotes. We're then asked if we want to ignore empty cells. Now we'll put true here. If you put false and any cells are empty, you'll get 2 delimiters next to each other. Whereas if you put true, it will just know that you don't want to include that. So you'll only get 1 delimiter between 2 given values. Then it's asking for the text items that we want to concatenate. So we'll use some hard-coded text. Then we'll use the month. And finally, the scenario. And if we changed the delimiter to a dash with a space either side, you can see that it's broken up the text accordingly. You may be wondering why I've chosen CHAR as a top formula for financial modelling. Well, the beauty of it is it allows you to break up this dynamic text onto different lines for formatting and presentation purposes. So we'll take what we've got here, we'll just set that back to a space delimiter. And then between the elements of text, we'll add a new formula, which is char 10. So if we put that in between each element of the formula, it's returned what we had before, but it's still on one row. Make sure that the wrap text is turned on for that cell. And now you can see that it's broken that onto separate lines. And this is really good for formatting text for presentational purposes. You can see that that's skewed a bit for the second two because we've used the space delimiter. If we change the space to nothing, you can see they're all lined put together. Here I've got a table of data to demonstrate the subtotal and the aggregate functions. Now on the left, I've got a set of data that I've totaled using the sum formula. So for half one of the year, I've just added up cells E4 to E9, for half two, cells E11 to E16, and the full year total, I've just put a sum formula in to add the 2 sum formula above. Now that's correct, but it could be quite limiting if you added in additional sections into a range or needed to expand this sum to add in more values. You'd have to remember to go back and do that. Whereas the subtotal function can add complete ranges but ignore all instances of itself, basically, the subtotal formula. In this instance, I'm going to use 9, which means it will ignore other subtotals. It won't ignore hidden rows. So if I put that in, you get the same result as the sum formula, the 66,000. And I've replicated that down here. You get the 59,000. The beauty of subtotal is that to add up the whole lot, you can just refer to the whole range and do a sum, and it will add everything except other subtotal formula. Now for the next column, I'm going to go for sum again, but this time I'm going to use option 109. And I've already done that down here, and it's returning exactly the same values. But the difference between 9 and 109 is that 109 will ignore any rows that are hidden. If I hid row 8, it's got the value of 7,000. You can see that the subtotal for half one drops to 59,000, and the total for the year, referring to the whole range again, but ignoring hidden rows, will still ignore the subtotals above it, but also ignores the 7,000 that's hidden. Aggregate is a newer function in Excel and works similarly to the subtotal, but has a wider range of functions. So again, you can sum, count, average, but you can also call things like large and small. So the first largest value would be the same as max, the first smallest value would be the same as min, but you could call the second largest, the fourth smallest values. Let's just go with sum again. And then we're asked, what do we want to ignore? So this builds on the subtotal function because it gives you much more flexibility. Rather than having to use different function numbers, you can tell it straight away here to use option 1 to ignore hidden rows, option 2 to ignore error values, option 3 to ignore hidden and error, as well as everything else, and so on. But we'll use option 0 just to ignore nested subtotal and aggregate functions. So it won't just ignore aggregates, but it will ignore instances of the subtotal function as well. And we'll add up those values there. So again, we've got our totals, and it's bringing us exactly the same values. If we hid a row, it wouldn't make a difference here because we've set it to not ignore hidden rows, but we could have done by using option 1 instead of a 0 here. There are a couple of things to watch out for with aggregate. Now down the bottom here, I've used a formula that's using the large option, ignore nested aggregates and subtotals, picked up the whole range above, including the nested aggregates. And then you have an additional argument relating to the large function, as in which largest value do you want to return. And actually, I don't want the first one, I want the second largest value. So in that whole range, ignoring the nested aggregates, you can see that the second largest value it says is 14,000. But if I wanted to incorporate a calculation in that aggregate, it stops ignoring the nested aggregate and subtotal functions. If I said I wanted to only pick up the values greater than 10,000 by turning those into true or false values. It now says the second largest value in the range is 66,000, which is one of the aggregate formula, which is wrong if you wanted to ignore those nested ones, so it's something to watch out for. The other thing to be wary of with aggregate, if you were sharing this model with someone that was trying to load it into Google Sheets, the aggregate function would not work. The let function is one that allows you to make your formula clearer for users to understand. Here I've got a little table of data. I want true or false values in the break-even column based on whether the sales value is more than or equal to the break-even value. So the first variable I'm going to use is sales. So you declare the variable name first and then the value. So for sales, I'm looking at E4. Break even 2, and then our calculation is required. So we're looking for whether sales is greater than or equal to break even. And in this instance, it's true. I could copy that formula down, or I can turn that E4 into a dynamic range, and that will then spill the let formula down. Now this is a very simple example, but you can imagine that when you've got very complex formulas, this does add a huge amount of clarity to what's going on in a formula, particularly as you can give things custom variable names to help explain what's happening there. Another benefit of the let formula is if you're calculating something over and over again in a formula, you can just create a variable to calculate it once, and then let will just refer to the value returned from that variable every time without recalculating the same value over and over again. Again, a simplistic example here, but I've got two formula which return the same value. You can see the top one, which is multiplying these two numbers together, then multiplying that total by the total of the two numbers again, and then again, which gives you a value of 8 million. But it's having to do that calculation of W times X 3 times to get the answer. Whereas the version below, using let, we've declared a variable calc, and it's multiplying the two values together. Then the calculation is just taking that variable value that's been returned and multiplying that by itself. So rather than calculating this bit 3 times, it's only calculating it once and then using it as the input to the formula. So if you've got formula that are recalculating the same value within them more than once, and you have a lot of those formula, then using let could really simplify that and probably speed up your workbook as well. You'll be employing far more functions in your workbooks than those I've been through here, but these are a good starting point for building structured, robust, and intuitive models. Please let me know in the comments what other formula you consider fundamental to good model building. Just don't mention VLOOKUP or its counterpart HLOOKUP. Please stick to XLOOKUP or use INDEX with MATCH or XMATCH. Thanks for watching.